Good morning, Prep 2. Okay, here is the Unit 2, Lesson 2, Wave Nature of Light. Wave Nature of Light. We all know that the light is a form of energy, and when it reflected from objects and falling on eyes, it causes vision. Okay, so what is the nature of light waves? Or what is the way, what are its properties? Okay, and here is in this lesson we will study all these properties of light or of wave light. But first of all, we want to know what is the light is. What is the light is, or what meant by light? Light is an external factor that affects the eye, causing the sense of vision. If you remember from Unit 2, Lesson 1, sound, it's the external factor that affects the ear, causing the sense of hearing, if you remember. Okay, here is the light, and it is external factor that affects the ear, causing the sense of vision. Okay, in this lesson, we will study these 6 properties. Number 1, the nature of light waves. Number 2, analysis of white light. Number 3, energy of light wave. Number 4, light behavior through different medias. Okay. Number 4, light travel in straight lines. Number 6, light intensity. Okay, we will begin with the first properties, the nature of light waves. Light waves are electromagnetic transverse wave. Electromagnetic transverse wave. Give reason. Here is a give reason why light waves are electromagnetic transverse wave. The answer, because they propagate through vacuum, and they are transverse wave because the media particles vibrate perpendicularly to the direction of wave propagation, forming a crest and troughs. Okay, number first you will talk about the electromagnetic waves as it propagates through vacuum. Okay, they don't need a medium to propagate through it. Number 2, you will say why it's a transverse waves, because the medium particles vibrate perpendicular to the direction of the wave propagation, forming crests and troughs. What about the light velocity or the speed of light waves? It's the speed equals or يعني بتكون velocity بتاعتها أو speed بتاعتها 3 times 10 power 8 meter per second. Okay, it's very important in choose in the final test. Okay, the speed of light. What is the speed of light? It's the distance covered by light in 1 second, and from this definition we will get through it with a conclusion in the law of speed of light. And the law says the speed of light equals distance represented by m small, okay, divided by time, represent with a second as a measuring unit. Okay, here is visible light, and it's one of the components of electromagnetic spectrum. Okay, of wave ranges between 318 to 700 nanometer. And here is electromagnetic spectrum shows the seven colors of wave light, and we will talk about it in the next property of light wave, and it's called analysis of white light. Analysis of white light. Okay, what meant by that? What meant by analysis of white light? It's a splitting of white lights into 7 colors called spectrum colors. Again, what is the analysis of white light? Okay, it's a splitting of white light into 7 colors called spectrum colors. And they are red, orange, yellow, green, blue, indigo, violet. Okay, you have to keep it in this range. And for example, you can see them if you put a compact disc CD on a table, okay, on the surface faces sun rays. It must face the sun rays, okay. You can see those 7 colors clearly, okay. And because the white light divided into or splitting into 7 colors in the sunlight, okay. And the next video we will continue these properties of light waves. Okay, thanks. After we take the first and second properties of light wave, we will continue the third one, energy of light wave. We have a German scientist called Max Planck proved that the energy of light waves is composed of energy quanta that called photons. Okay, so he discovered the photons the same as the light wave is decomposed of energy known as photons. The energy of photons represented by E capital is directly proportional to the frequency of light waves, as we see here in the relation between the energy of the photons is directly proportional to the frequency of light wave. Okay, and here is the symbols of directly proportional. Okay, this is, and we will continue our lesson. Here is the figure that shows us the range of the produced sounds and hear sound by some living organism. Okay, here is a human as you see in 20 kilohertz, 20 hertz. Okay, I have a dolphin here. It goes to 140. Okay, and that just shows the frequencies of the sound wave that we have taken. For example, okay, give reason. Dogs can't hear or can hear all sounds produced by man. Okay, why? Only because the range of sounds produced by man lies within the range of sound heard by dogs. Okay, it is the same range of the sounds. Okay, on the other hand, man can't hear sound produced by a dolphin or a bat. Why? Only because a dolphin or a bat produces ultrasonic waves, okay, while the human can't hear sounds of frequencies more than 20 kilometers. Okay, here is some real life applications. They are very important. Very important in three fields like medical, industrial, metallurgy. Okay, number one, the uses of ultrasonic waves. Okay, in the medical field, breaking down kidney and ureter stones without any surgical intervention or operation. Number two, diagnosis of male prostate gland tumor and its as ultrasonic waves are characterized by their high ability to kill some types of bacteria and stop action of some virus. Okay. Number three, in military field, the discovery of land mines. Okay, Here is a revision for this lesson. Okay, sound, its external factor that affect the ear, causing the sense of hearing. Oh, there is a law of sound. Here is sound wave velocity represented by V equals wave frequency represented by F times wavelength. Okay, the human ears can differentiate between the sound through the three different factors, or we call it the properties of sound. Number one, sound pitch. Number two, sound intensity, sound quality. Sound pitch, its property by which the ear can distinguish between harsh and sharp voices. Okay, and here is the law. Sound frequency, okay, represented by F equal number of cycles represented by D times the number of gear of teeth represented by small n, okay, divided by time in second represented by T. Number two, sound intensity. This is the properties by which the ear can distinguish between sound, either strong or weak sound. Okay, it's the intensity factor affecting the sound intensity. There are 5 important factors with a lot of good reasons. You have to pay attention for them. Number one, the density between the ear and the sound source. Number two, the amplitude of vibration of the sound source. Number three, the area of the vibration or vibrating surface. Number four, the density of the medium through which the sound travels. Okay, number four, the direction of the wind. The inverse or square law of sound. The intensity of sound at point is inversely proportional to the square of the density between that point and the sound source. It's very important. Okay, the intensity of sound is inversely proportional to the square of the distance between the sound source and the ear. It's directly proportional to the square of the amplitude. It's directly proportional to the density of medium in which the sound travels or propagates. Increases when the sound source touches a resort, a body or box. The last one increases when the sound direction is in the wind flow direction and vice versa. Okay, number three, the quality of the voice, our sound quality. It's a property by which the human ear can distinguish between different sound according to the nature of source. Okay, even if they are equal in intensity and pitch. Harmonic tones, they are important. They are the tones that accompany the fundamental tone, but they are higher in pitch and lower in intensity and different from one instrument to another. Okay, and here is the 3 types of voice of sound waves: infrasonic, and that the human can hear because it's lower than 20 hertz. Okay, can't hear by human. Okay, there is a storm sound. And here is the sonic waves. That is the only wave of sound waves that the human can hear because it's ranging from 20 hertz to 20 kilohertz. Okay, it's very important. It's a sonic waves. Ultrasonic waves, they are waves its frequency higher than 20 kilohertz. Only some animals can hear this type of sound waves. Okay, and thank you for this lesson. So next video we will continue the second lesson in unit 2. Thanks.